In this video, we're going to talk a little bit more about nonlinear inequalities. In particular, in this video, we're going to focus on rational inequalities. So in my last video, I kind of focused on quadratic inequalities, something like ax squared plus bx plus c is greater than, less than, or equal to 0, something like that. And so I'm going to assume that you already have an understanding of that kind of problem going into this problem, because this problem kind of builds on that kind of problem. So we'll start with the first relatively simple example. I have x minus 2 over x plus 2 is less than 1. And so I'll go ahead and write out my steps here. So my first step is I want to get the right-hand side equal to 0. So step 1, get the right-hand side equal to 0. So what I can do to do that here is I can subtract 1 from both sides in this equation, or in this inequality here. So I have x minus 2 over x plus 2 minus 1 less than 0. Cool. Now my second step is to get the left-hand side as one fraction. So get the left-hand side, or we'll say right, the left-hand side as one fraction. So in this case, I got x minus 2 over x plus 2 minus 1. And I want to put that as one fraction. So in order to do that, I would give these two terms here a common denominator so that I can add them. So what I'll do is I will multiply this 1 by x plus 2 over x plus 2. Okay. Now what I have is x minus 2 over x plus 2 minus x plus 2 over x plus 2 less than 0. I can rewrite this now under one denominator as x minus 2 minus x plus 2 in parentheses, very important, because this entire thing was being subtracted, over x plus 2 less than 0. Okay. Now I can combine like terms, so this negative will distribute here, and I will get minus x minus 2. So I'm left with x minus x will cancel, and I have 2 minus 2, which gives me negative 4 over x plus 2 less than 0. Great, I have one fraction. Now my third step is to find zeros of the numerator and the denominator. So find roots of the numerator and denominator. So I'll keep track of these in a little table here. So my roots of numerator and roots, just to keep things organized here. So roots of the numerator, so finding zeros of the numerator, we just set whatever is in the numerator equal to 0. So that would be negative 4 equals 0. But negative 4 is never 0, so I actually have no roots in my numerator. So I can write none. Roots of my denominator, so I just set whatever's in my denominator equal to 0. So in this case, that's x plus 2 equals 0. So x equals negative 2 is a root of my denominator. Okay. Now, step 4 is going to be to draw my number line here, my sign chart. So draw number line, and I'm going to plot my roots. Now, this is important. We're going to plot the roots of the numerator using the usual rules. So when I say usual rules, I mean if this is, in this case we have a less than, so I would give my zeros open dots. If it were less than or equal to, I would give them closed dots. And so if you're confused on what I'm talking about, go back and check out my last video on nonlinear inequalities. I believe it's called quadratic inequalities or something like that. But that will give you the rules for deciding if your points of your roots are going to be open or closed. But very important, if I plot roots of my denominator. So plotting roots of denominator are always open. So if I'm plotting the roots of my denominator, they are always open, and I plot both, okay? So drawing my number line here, I'll draw it down here. So So I'm going to I'll draw 0 here on my number line. -2 will be right here. And because it's a root of the denominator, I leave it open. So I'm not including it. And then I like to draw a little dotted line here to let myself know what regions I'm picking from. And I need to pick step 5, pick 2 test values, or not 2, but pick test values in each region. So 5 is pick test values between regions. So here I have 2 regions, this guy and this guy. So I can pick easily -3 as a test value, and I can pick 0 as a test value. And then step 6 is going to be test those values on the left-hand side to get the sign. So recall, what we're looking for is we're trying to solve this inequality, right? So we're trying to figure out when -4 over x plus 2 is less than 0, or in other words, when it's negative. So our whole goal is to find when this -4 over x plus 2 is negative. So we're going to plug in our test values to see what gives us a negative value. So plugging in -3 to that left-hand side there, I have -4 over -3 plus 2. -4 is a negative. -3 plus 2 is going to be -1, so it's also going to be a negative. A negative divided negative is a positive. So over here in this region, we are positive. Okay, testing out 0, I have -4 over 0 plus 2. That's a -4 over a positive 2, which gives me a negative overall. So in this region, I am negative. Okay, and our final step, step 7, is to write our interval. And there may be more than one, so we'll write our intervals. So note that we were looking for when this is negative, and we found that in this region we are negative, and that's everything from -2 to out to infinity there. So my interval is going to be open parentheses, -2, out to infinity. Right, because I didn't include -2, it's an open dot. And if you know anything about rational functions, you would note that x plus 2 is a denominator, or is an asymptote for this, because it's a 0 in the denominator, and so it would be undefined, and that's why we don't include it in our interval there. But yeah, so we note that this is our negative region, and so this is our interval that solves it, our inequality. Okay. So we're going to move on to this next example here. I think I'll go ahead and put it underneath, just that way we're taking up less space horizontally. Okay, so let's remember our steps. So our first step is to get right-hand side as 0. So 1, get the right-hand side equal to 0. It's already done for us for free, right? Now step 2 is to get the left-hand side as 1 fraction. And we're going to do that by giving these a common denominator to add them. I think one way you can think about this, one of my students brought up, was cross-multiplying. So we kind of just multiply by what's missing. So I have x over x plus 3 minus x over x plus 2 less than or equal to 0. Now I can multiply this guy by, so I have to write this like this. I can multiply this guy by, on the left here, by x plus 2 over x plus 2. So you can think about this as coming from here, and you can think about this as going here. So I'm going to multiply this guy by x plus 3 over x plus 3. I'm just giving them a common denominator is all I'm doing. So what I'm left with now is I have x times x plus 2 over x plus 2 times x plus 3 minus x times x plus 3 over x plus 2 times x plus 3 less than or equal to 0. Now I can go ahead and distribute these numerators here and give them a common denominator. So I'll do that at the same time. So I'm distributing these, each of these here, and then I'm putting everything under one denominator because they have a common denominator now. So in the numerator, I have x squared plus 2x minus x squared plus 3x over x plus 2 times x plus 3 less than or equal to 0. Now I can distribute this minus here and combine like terms. So I'll just go ahead and do this like this. So I have x squared minus x squared will cancel, and then 2x minus 3x is negative x. So I have negative x over x plus 2 times x plus 3 less than or equal to 0. Great. So step 2 is done. Let's see, what was our step 3? We want to find roots of the numerator and the denominator. And I'll draw that little chart here. So 3, find roots, find roots of the numerator and the denominator. So I'll have roots of numerator over here, and I'll do roots of denominator over here. So remember, I'm just setting the top and bottom equal to 0, so numerator is negative x equals 0. Well, that just means x equals 0, so that's my root of the numerator. And then roots of the denominator are going to be when the entire denominator is equal to 0, so x plus 2 times x plus 3 equals 0. Well, that's easy. Zero product property tells me that it's going to be x plus 2 equals 0 and x plus 3 equals 0. So x is going to equal negative 2 and x is going to equal negative 3. So those are my roots there of the denominator, negative 2 and negative 3. My roots of the numerator are x equals 0. Okay. Now step 4 is going to be to draw my number line and plot my zeros. And remember, roots of the denominator are open. And in this case, we have less than or equal to. So this root of the numerator is going to be closed, right? We use the regular rules. So let me go ahead and draw my number line here. So 0 is going to be closed. This is going to be 0. And then negative 2 and negative 3 are going to be open. So this will be negative 2 and this will be negative 3. Okay. I like to draw little dotted lines to let me know where my regions are, where I need to pick my test values, because that's step 5 is to pick test values in my regions. Okay, so I think in this region over here on the far left, I will pick negative 4. I'll pick, we'll say, what's between negative 2 and negative 3? Well, what about negative 5 halves? I can pick negative 1 pretty easy in here, and I can pick 1 pretty easy out here. So those are going to be my 4 test values. Okay, and remember, our goal is to find when this happens, that is when our left-hand side here is less than or equal to 0. So when it's 0 or negative is what we're looking for. So let's go ahead and do step 6. Let's plug in our test values. The sign of the left-hand side. So testing negative 4, we have negative 4 over negative 4 plus 2 times negative 4 plus 3. That is a positive 4, so it's going to be a positive over negative 4 plus 2 is going to be negative, that's going to be negative 2, and negative 4 plus 3 is also going to be negative, that's going to be negative 1. So I have a positive over a negative times a negative. Well, a negative times a negative is a positive, so I have positive over positive, which is positive. Okay, so out here we are positive. Okay, next plugging in negative 5 halves. We have negative 5 halves over negative 5 halves plus 2 times negative 5 halves plus 3. Okay, negative 5 halves is going to be positive 5 halves. And then we said that negative 5 halves is less than negative 2, right? It's less than negative 2. So I'm subtracting 2 from something that's greater than 2. Sorry, I'm subtracting from 2 something that's greater than 2. So this is going to give me a negative. 2 minus 5 halves is going to be negative. Now, we know that 3 is larger than 5 halves, so it's subtracting 3 by something smaller than 3. This is going to give me a positive. So I have a negative over, a positive over a negative times a positive, which is going to be a positive over a negative, which is going to be overall negative. So we are negative here. Okay. Now testing -1, I have -1 over -1 plus 2 times -1 plus 3. That gives me a positive over a positive times a positive. I hope you can see that we are all positive, so we're getting a positive here. So in this region we are positive. And then finally testing +1, we have -1 over 1 plus 2 times 1 plus 3. That gives me a negative number over 1 plus 2 is positive, 1 plus 3 is also positive. So I have a negative over a positive times a positive, which I hope you can see is overall negative. So we're also negative here. Great. Okay, so what are the regions we care about? We care when we're negative or when we're 0. So that is, we're caring about this region here. So between -3 and -2. And everything from 0 onwards, right? That's where we're negative. So step 7 is going to be write our interval. And in this case, we have more than 1. So it's going to be everything between -3 and -2. Remember, it's open because we didn't include those. They're open. So we use parentheses. And then along with, that's union, everything including 0, because 0 was one of our roots of the numerator. We included that. It's a solid dot onward to infinity. And that is the solution. Okay, and those wrap up. Okay, and that wraps up kind of what I wanted to say about rational inequalities. Those are 2 pretty good examples, I feel like. So I'll go ahead and end the video here. If you found this helpful, please consider liking or subscribing. Thanks.